Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Relational Database and SQL, Part 14, SQL Joins, Cartesian Product, Cross Product, Equi Join, Inner Join, Outer Join, Left Outer Join, Right Outer Join and Natural Join for Class 12 students of Computer Science. So, let's dive in and get started. Let's learn about SQL joins. What is the meaning of join? Join means to combine something. In case of SQL, join means to combine two or more tables. Now come to the definition of SQL join clause. It is used to combine rows from two or more tables in a relational database. It is based on a common field, related column, between the tables. How can you query with join? When using join in a query, more than one table is specified in the from clause. Join process or function. The process or function of combining data from multiple tables using the join clause is referred to as a join. Some key points to remember about SQL joins. SQL extracts data from related tables using physical or virtual joins. Joins involve specifying conditions on related attributes using the where clause. Unlike Cartesian Product, joins retrieve specific related data. The join clause is used in SQL, and conditions are specified within the from clause. Typically, related attributes are a primary key in one table and a foreign key in another. When using examples, you can understand better. First, let's learn about the types of SQL joins. Cartesian Product, Cross Product, Equi Join and Natural Join. We are going to learn this in detail. Cartesian Product, Cross Product. The Cartesian product is also known as cross product or cross join in SQL. It is a binary operation denoted by cross that combines two sets or relations. The degree, number of attributes or columns, of the resulting relation is the sum of the degrees of the two original relations. The number of tuples in the new relation is equal to the product of the number of tuples in the two tables or relations involved in the Cartesian product. Example, if A equals 1, 2, 3. And B equals A, B, C. Find A cross B. Cartesian product for A cross B is 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B and 3C. So, columns after Cartesian product equals 1 plus 1 is equal to 2, rows after Cartesian product equals 3 cross 3 is equal to 9. Let's see an example for Cartesian product. Look at the blue box. This is a student table containing 5 records named Joel, Steve, Jenny, Daniel, and Emily. Look at the yellow box. This is an instrument table containing 2 records named keyboard and guitar. Now, look at the green table. Cartesian product of student cross instrument. Look at the query in the green box. Select name, _name from student, instrument, semicolon. Therefore, a Cartesian product is formed when no join conditions exist or are invalid. When we perform Cartesian product between two tables student and instrument, all the rows in the first table student are joined to all the rows in the second table instrument. Look at the output in the green box. Joel guitar, Joel keyboard, Steve guitar, Steve keyboard, Jenny guitar, Jenny keyboard, and so on. Using Cartesian product operation results in a large number of rows as the output, so it is seldom used, that is rarely used. Next we learn about the Equi Join. An Equi Join is a simple SQL join condition that uses the equal to sign as a comparison operator for defining a relationship between two tables on the basis of a common field, that is, primary key and foreign key. The syntax is select column 1, column 2 goes on, from table 1, table 2 where table 1. Primary key column equal to table 2. Foreign key column semicolon. Let's see an example. Look at the blue box. First we create a database named school. Next, look at the yellow box. We are using the database school. Next, look at the green box. We are creating a table student with roll number as int data type and primary key. Look at the red box. We are inserting 3 records. Now look at the pink table on the right side of the screen. Yes, you can see the table student with 3 records. Look at the blue box. We create another table named fees. Here, roll number integer data type, fees integer data type foreign key of roll number references student of roll number. Look at the green box. We are inserting values into table fees. Watch out that we inserted only fees for roll number 3 and 1. Because, in some cases, students wouldn't have paid the fees. So in the output it returns null value. Look at the pink box. The table fees looks like this. Now let's write a query with Equi Join. You can see the table student in the green box. Table fees in the blue box. Now look at the yellow box, the statement in the MySQL prompt. Select a.rollno, a.name, b.fees from student a, fees b, where a.rollnumber equals b.rollnumber . First you have to understand this query. In this query, we have used table aliases. A table alias is a temporary name given along with the table name in from clause. To cut down on the amount of typing requirements in your queries, you can use table aliases for table names in select and where clauses. In the given select statement, A and B are the alias names, alternate names, for the tables student and fees respectively. So, we can always use alternative name in place of primary name for the 2 tables to be joined. So now look at the output in the red box. The 2 table contents are joined together. Column name roll number, name and fees are joined together, which matches the roll number in both tables. You can also perform Equi Join by using join keyword followed by on keyword and then specifying names if the columns along with their associated tables to check equality. The syntax is select column 1, column 2, from table 1, join table 2, on, join _ condition, semicolon. The same query can be written using join clause. Look at the yellow box. In the MySQL prompt, we type the statement select a.rollnumber, a.name, b.fees from student a, join fees b on a.rollnumber equals b.rollnumber . In this query, student a and fees b are the aliases for the student and fees tables, respectively. The join clause is used to combine rows from both tables based on the common column roll number. The on keyword specifies the condition for the Equi Join, in this case, a.rollnumber equals b.rollnumber. This query is equivalent to the original query but uses the explicit join syntax with the on keyword for better readability and consistency. Equi Join is further classified into inner join and outer join. Outer join is classified into left outer join and right outer join. Let's discuss about the inner join or intersection. Intersection of common rows. Inner join retrieves only the rows that have matching values in the specified columns from both tables involved in the join, resulting in the intersection of the 2 tables. Look at the picture below. The inner join is the intersection of table 1 and table 2. Equi Join subset. Inner join is a subset of Equi Join, where the join condition is based on equality between columns, and it eliminates rows where the join condition evaluates to null, ensuring that only matching rows are included in the result set. Let's see an example. Look at the green box. It's the student table. Look at the blue box. It's the fees table. Now look at the yellow box. In the MySQL prompt, we type the statement select a.rollnumber, a.name, b.fees from student a, fees b, where a.rollnumber equals b.rollnumber, order by a.rollnumber . The query retrieves the roll number and name columns from the student table and the fees column from the fees table, where there are matching roll number values between the two tables. The result set is then sorted in ascending order based on the roll number column from the student table. Look at the query again for more explanation. First, we look at the table alias and columns. We are selecting a.roll number, a.name. These refer to the roll number and name columns from the student table aliased as A. Next we have b.fees. This refers to the fees column from the fees table aliased as B. Next we see the join condition, where a.roll number equals b.roll number. This is the condition used for the join, specifying that the roll number column from table A, student, should match the roll number column from table B, fees. This ensures that only rows with matching roll number values from both tables are included in the result. Instead of where clause, we can use inner join also. In the next screen, we can learn how to use inner join instead of where clause. Last we have order by clause. Order by a.roll number. This clause orders the result set based on the roll number column from table A, student, in ascending order. Look at the red box. Roll number 1 holds the name Alex with fees 1,000 and roll number 3 holds the name Johnson with fees 1,500. Roll number 2 with name James does not match with fees in the table fees and hence not displayed in the result. Now we have a brief explanation. Inner join retrieves only the rows that have matching values in the specified columns from both tables involved in the join, resulting in the intersection of the two tables. Look at the picture. Table student has the alias name A, and table fees has the alias name B. Here roll number column is marked in yellow, name column in green and fees column in blue for your easy reference. Now look at the red box below. The second line of the statement or query in the MySQL prompt. The inner join clause explicitly specifies the join condition on a.roll number equals b.roll number, indicating that only rows with matching roll number values from both tables should be included in the result. The alias A and B are used to refer to the student and fees tables, respectively, just like in the original query. The order by clause remains the same, sorting the result set by roll number from table A in ascending order. The same resultant table can be seen below after executing the query. Let's learn about the outer join. Outer join is classified into left outer join and right outer join. Let's learn about the left outer join. The left join keyword returns all rows from the left table, table 1, with the matching rows in the right table, table 2. The result is null in the right side when there is no match. Let's see an example. Look at the green box. It's the student table. Look at the blue box. It's the fees table. Now look at the yellow box. In the MySQL prompt, we type the statement, select a.roll number, name, fees from student A, left join fees B, on a.roll number equals b.roll number semicolon. Now, in this query look at the table alias and columns. A.roll number. This refers to the roll number column from the student table, aliased as A. Name. This refers to the name column from the student table, as it's not explicitly aliased. Next is fees. This refers to the fees column from the fees table, aliased as B. Look at the second line. From student table alias name, A, next we can see the join condition. Left join fees B on A.roll number equals B.roll number. This specifies a left join operation between the student table A and the fees table B, where the join condition is that the roll number column from table A, student, should match the roll number column from table B, the fees. Let's view the result set. The query retrieves all rows from the student table, A, regardless of whether there are matching rows in the fees table, B. If there are matching rows in fees, the corresponding fees value is included, otherwise, null is returned for the fees column. Explanation of left join. A left join returns all rows from the left table, student A, and the matched rows from the right table, fees B. If there is no match, null values are returned for the columns from the right table. The result set would contain the roll number and name columns from the student table, along with the fees column from the fees table, where available. This query essentially fetches information about students' fees, including those who haven't been charged any fees, hence utilizing the left join to ensure all student records are accounted for. Look at the red box. Roll number 1 and 3 holds fees value 1,000 and 1,500 respectively. But roll number 2, James' record holds the value null, as on the right side table named fees, doesn't hold any match. Let's learn about the right outer join. The right outer join keyword returns all rows from the right table, table 2, with the matching rows in the left table, table 1. The result is null in the left side when there is no match. Let's see an example. Look at the green box. It's the student table. Look at the blue box. It's the fees table. Now look at the yellow box. In the MySQL prompt, we type the statement, select statement. This part of the query specifies the columns that you want to retrieve from the result set. In this case, you're selecting roll number and name from table student, aliased as A, and fees from table fees, aliased as B. Next line, we have from clause. Here, we're specifying the tables from which we want to retrieve data. We're performing a right join, which means we want to include all rows from the fees table, the right table, and only the matching rows from the student table, the left table. The join condition 0n, A, dot roll number equals B dot roll number ensures that only rows with matching roll numbers between the two tables are included in the result. Order by clause. This clause is used to sort the result set based on the fees column from table fees, aliased as B, in descending order, DESC. So, the query will return a result set that includes the roll number and name from the student table and the fees from the fees table, where there are matching roll numbers between the two tables. The result will be sorted based on the fees column in descending order. Look at the red box. Records are displayed in descending order. Record 3 holds name Johnson with 1,500 fees and Record 1 holds name Alex and 1,000 fees. Let's revise the types of joins. Inner join. This type of join returns only the rows where there is a match in both tables. Left join, or left outer join. This type of join returns all the rows from the left table, and the matched rows from the right table. If there is no match, null values are returned for the columns from the right table. Right join, or right outer join. This type of join returns all the rows from the right table, and the matched rows from the left table. If there is no match, null values are returned for the columns from the left table. In SQL, the join in which only one of the identical columns exists is called natural join. Let's see the explanation. Listen carefully. A natural join is a type of join operation that automatically matches columns with the same name across two tables. When you perform a natural join, the resulting table includes only the columns that exist in both tables, and it combines the rows from both tables where the values in the matched columns are equal. It is similar to Equi Join except that duplicate columns are eliminated in natural join that would otherwise appear in Equi Join. Now come to the second point. In natural join, we can also specify the names of columns to fetch in place of star, which is responsible for the appearance of common column twice in the output. Listen carefully. The SQL natural join is a type of Equi Join and is structured in such a way that columns with the same name of associated tables will appear only once. There are two conditions for natural join. First condition is, the associated tables have one or more pairs of identically named columns. Second condition is, the columns must be of same data type. Note that, in natural join, the join condition is not required. It automatically joins based on the common column value. Natural join is an alternative method to Equi Join. The syntax of natural join is select star from table 1, natural join, table 2 semicolon. Let's see an example. We have the two tables student and fees on the top of the screen. Now, we are going to use natural join with these two tables. Look at the yellow box. In the MySQL prompt, we type the statement, select star from student natural join fees semicolon. This query performs a natural join between the student and fees tables based on the common column roll number. It retrieves all columns from both tables where the roll number matches. It effectively combines the data from both tables based on the common roll number. Now, look at the red box. In the result of the final query, you can see that it combines the data from both student and fees tables, showing the roll number, name, and fees for each student where there is a match on roll number between the two tables. So roll number 3, name Johnson and fees 1500, and roll number 1, named Alex with fees 1000 are displayed. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and relatives. Watch the upcoming videos, Interface Python with SQL Part 1. You can check the link in the description box given below.